You know, aldehyde ketone, we have C double bond O, C double bond O, okay? In aldehyde, we have C double bond O and H. In ketone, we have C double bond O connected with two alkyl groups. Okay. First aldehyde. Oh, so sorry, I forgot to. Sorry, I forgot to record it. Okay, record it now. Okay, I say again. In the chapter, we study aldehyde and ketone. In aldehyde and ketone, we have C double bond O, and in aldehyde we have C double bond O connected with hydrogen, and ketone C double bond O connected with two alkyl groups. Okay. Let's say for the aldehyde, for the nomenclature of aldehydes, we use the name of, for the common name, we use the name of carboxylic acid, and then delete ic acid and replace ic acid by aldehyde. So, for example, we have acetic acid, and then we delete ic acid and we add aldehyde. So it becomes acetaldehyde. Okay, that is for the common name. For the IUPAC name, they use the name of hydrocarbon and add Al. For example, the IUPAC name of acetaldehyde is ethanol. Ethanol. Okay, that's just the name. For the ketones, okay, we just call the name of two alkyl groups and then ketone. For the IUPAC name, we have the name of hydrocarbon and add O and E. Okay, okay. That's the name of the aldehyde ketone. That's the name of the aldehyde ketone. Sorry. So how to make aldehyde ketone? We can make aldehyde ketone from alkene C double bond C. Okay, by ozonolysis. Okay, so the ozone will cut the double C double bond C, and then we have two carbonyl structures. Okay, but it's very easy to oxidize aldehyde to carboxylic acid. Okay, so if you want to get the aldehyde, you need to use a reducing agent. Okay, like zinc in acetic acid. Okay, if we don't have this reducing agent, aldehydes we oxidize to carboxylic acid. Of course, the ketone is stable, but for example, in this case, the red ketone is stable, so it stay there. But if we don't have reducing agent, this aldehyde, the green aldehyde, could be oxidized to acetic acid. Okay, that is the first one. Second one, we can have aldehyde ketone from C triple bond C. Okay, from C triple bond C. Okay. C triple bond C, we have Markov-Nikov addition. Markov-Nikov addition with water, mercury, sulfate, and sulfuric acid. And we have Markov-Nikov addition, this Markov-Nikov alcohol. Okay. And actually, in this case, it is an anone. Okay, anone. It is tautomerized to ketone. If we use boron and then oxidation, we have enone, and the enone is converted automatically to aldehyde. Okay. Remember, in the midterm exam, both midterm and final, you will see these two reactions, so be careful. And of course, we can oxidize alcohols to carbonyl structure. Secondary alcohols will be oxidized to ketones, and ketones are stable, so nothing happened after that. But for aldehyde, if we oxidize primary alcohol, the primary alcohols can be oxidized to aldehyde first. But it's very easy to oxidize aldehydes to carboxylic acid. Okay, so eventually we have carboxylic acids. Okay, if you want to get the aldehyde, the only oxidizing agent is PCC. Okay, PCC. PCC is a soft oxidizing agent. Okay, we use PCC in dichloromethane. Okay, and then we have the aldehyde. If we use other oxidizing agent, we have the carboxylic acid, not the aldehyde. Okay. Okay, we can make aromatic ketone by the Fidel-Crafts acylation reaction. Okay, Fidel-Crafts acylation reaction. Sorry, I have the phone. Sorry. The Fidel-Crafts acylation reaction. There are two ways to carry out the Fidel-Crafts acylation reaction. We can use acyl chloride or anhydride. Okay, with Lewis acid catalyst. Okay, then we have aromatic ketones. Just ignore this reaction. Okay. Okay, that's how we make aldehyde and ketones. Okay, so what is the typical reaction of aldehyde and ketone? You know, in aldehyde and ketone, we have C double bond O, C double bond O, C double bond O, and in oxygen is electron withdrawing. Oxygen is electron withdrawing. So the carbon become partially positive, partially positive. Okay, can you wait a minute? There's something wrong with my throat. Okay. Okay, so this carbon is positive, so something negative will attack this positive. So we have nucleophilic addition. We have nucleophilic addition. Okay. Negative attack to positive, so we have nucleophilic addition. Nucleo in English, philic means love or like. Nucleo means positive, so nucleophilic means love positive. In order to be able to love positive, the attacker must be negative. Okay, so this is nucleophilic attack. Okay, for example, the first example is the reaction of Grignard reagent. Grignard reagents. Grignard reagents. Okay, you know, in Grignard reagent, this carbon is negative. Okay, negative. This carbon is positive, so negative add to positive. So we have nucleophilic attack. Okay, and then this add to double bond, so we have nucleophilic addition. Okay, negative add to positive, and positive magnesium we add to negative oxygen, and then we have this one, and then after hydrolysis we have alcohol. Okay, we have many examples here, the same mechanism. Okay, or we can use cyanide or acetylide, C triple bond N cyanide, or acetylide. So negative add to positive, negative add to positive. So we have the same thing. Okay, nucleophilic. But we have two important reactions. Look, after we have C triple bond N, if we carry out the hydrolysis, we have carboxylic acid, and we have hydrogen. This become amine. So everyone take note these two reactions. Take note carefully. Take a note here. 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 Okay, you will see these two reactions in your final exam. Okay, Okay. Next reaction with amines. You know, C double bond O, oxygen is withdrawing, so this carbon is positive, oxygen is negative, partially. Okay, I say again, this carbon is partially positive, the oxygen is partially negative. Look at the amine, a nitrogen. The nitrogen is a little bit negative because on nitrogen we have 2 electrons. So negative nitrogen will attack to the positive carbon, and we have nucleophilic attack. Okay, and after we remove one water molecule, so we have something called imine, C double bond N, imine. That is for primary amine. For secondary amine, we have the same mechanism. The negative oxygen, the negative nitrogen, you attack to the positive carbon, then we have nucleophilic attack. And after that, we remove one water molecule, but only one hydrogen here. So we need to remove the hydrogen here. So eventually we have C double bond C N, and we call it an enamine for secondary amines. Okay. Aldehyde ketone can react with water, the same mechanism. Okay, but we don't like this reaction. You can ignore this reaction. Okay, now we move to an important reaction. That is reaction of alcohols. Reaction of alcohol. Reaction of alcohols. You know, alcohols. Okay. Sorry, wait a second. Continue. Now we go to reaction with alcohols. This is important. This is important. Okay. So look, you know the carbon in C double bond O is positive. The oxygen is negative. So negative attack to positive. So we have nucleophilic addition. Okay. Okay. If we don't use acid catalyst, the reaction occurs slowly. If we add acid catalyst, so the proton we add to the negative oxygen, so making this carbon become more positive. Okay, more positive. So this negative, it's easier for this negative oxygen to attack the positive. Okay, so when we have acid catalyst, the reaction proceeds faster. Okay. Okay, and one more. So after you have the product, after we have the product, this is a product. Okay, this is a product here. You know, if we use acid catalyst, the one proton will combine with this OH, and we remove one water molecule. Okay, and this carbon become positive, and the second molecule of alcohol, I mean another methanol molecule will attack to this carbon. So eventually we have C with 2O. Okay, C with 2O. Okay, so if we use excess alcohols, okay, eventually we have C with 2O. And this is the reversible reaction. This is the reversible reaction. Okay, this is reversible reaction. If we add water to this product, the equilibrium will shift from the right to back to the left. Okay, so we can shift the equilibrium from the left to the right if we use excess alcohol. Okay, and after we have this product, if we add water to the product, the equilibrium will shift from the right back to the left. Okay. Okay. So what is the application of this one? What's the application of this one? Application of this one. What is the application of this one? So I give you one example, and remember this is very, very important. examples so that you can understand the application of this method, or sorry, of this reaction. Okay, let me stop sharing it and give you one example in Chem Office. This is very important. This is very important. Chapter 11, let me say that of this reaction. Let me open the Chem Office. Okay. Okay. Let me share the screen. Can you see my screen? Can you see my screen? Everyone, can you see it?
Yeah.
Okay, so now make this carboxylic acid from this one magnesium and CO2. Okay. Okay. So I give you 15 minutes to do it. Okay. 15 minutes to do it. And then upload your answer onto BKL Learning. And after that, I will explain the application of this important reaction. So upload your answer to week 10. Okay. Have you done? You need to submit your answer onto BKL Learning, but you need to use the reaction with alcohol to protect the aldehyde group. You know the Grignard reagent. The Grignard reagent. If you react this with magnesium, and then we have this one. Okay, then you have this one. Okay, you have this one. Let me. Okay. But you know that this one can react with CH4 here. Okay, so eventually this molecule of this one will react with other molecule of this one. This magnesium will react with this aldehyde. So eventually we don't have this one. Okay, sorry. Eventually we don't have this one. Sorry. Eventually we do not have this one. What's wrong with it? Where is the line? Where is my line? Sorry. So eventually we don't have this one. Okay. Do not use this method, okay? Okay. Do not go with this way. You know, the magnesium, the Grignard reagent will react with the C-O. So we cannot go with this way. Okay. Okay. So you need to protect the C-O. Okay. Okay, so we cannot add magnesium here because this one will destroy this one. Okay, so first we need to add we can add ethanol C2H5OH. We can add 2 molecules of ethanol. Okay, but In fact, people use this one. Ethanol is flammable, so people use this one. People use this one, okay? And some SO3 this acid catalyst. Acid catalyst, okay. And then we can have this one. Okay, sorry. File memory. Okay, you know we can use 2 molecules of ethanol. Okay, so to add 2 COH5 here, but even actually, in fact, people use this one because this one is better. Ethanol is flammable. Okay, okay. So now we don't have C double O, no more C double O's. Then we can add magnesium. Okay, this we can add magnesium. Magnesium. Okay, okay, and then we have magnesium. Okay, okay, and then you know no more C double O here, so we can have magnesium here, and then we have number 1 CO2 and number 2. Okay, sorry, plus. Okay, this one will hydrolyze the product of the linear reaction with CO2, and then this one will hydrolyze this one back to the aldehyde. Okay, this is the way to make this carboxylic acid containing the C double O in the molecule. Okay, do you have any question here? Do you have any question here? If you don't understand, please ask me. Okay, please ask me. Okay. How the first reaction work? How the first reaction work? You mean which reaction? You mean this reaction?
Yes.
Okay. Okay, the first reaction. Okay. Let me stop sharing it and then share the handout again. Okay, let me share the handout. If you don't understand, please ask me. You will see it again in your exam. Okay. Can you see my handout? Can you see my handout back? My lecture notes? Can you see it?
Yes.
Okay. That reaction is this reaction. You know, first we have C double O react with the first molecule of methanol, and then we have OCH3 here. And the second molecule of methanol, so we have one more OCH3. Okay. Okay. Read this reaction carefully. Okay. So this is the first oxygen, the second oxygen. So we have OCH3, OCH3 here. In your exam, in your example, this C and this C connect with each other. So we have a ring. You understand?
Oh, I see.
Okay, let me say it again. 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 Where is it? Where is my... Okay, here. Can you see it again? Can you see the chemtrail? Can you see my chemtrail?
Yes.
Okay. Okay. So this is the first oxygen and the second oxygen. The same reaction. The only difference here is this C and this C connect with each other. So we have a ring here. Okay. So this is the application of the reaction between alcohol and aldehyde. Okay. You understand?
Yes, I understand now.
Okay, thank you. Do you have any question? If you don't understand, ask me. Ask me. Ask me. Ask me. If you understand, ask me. Ask me. Let me stop sharing it. Please stop. Let me continue. Where is my lecture? Okay, done. Okay. Okay. Ignore this reaction. Ignore the action. Actually, the same mechanism with the OH. Okay, but in your exam, you don't have a question related to sulfurs. Ignore it. Okay, then here comes the Wittig reaction. This is extremely important reaction. You will see this reaction in your midterm exams and your final exam. I told you already. Okay. So now look at C double bond O and the unit P double bond C. Okay, it's very easy. You just delete the O and delete the P and combine the rest. And then you have a new C double bond C, a new C double bond C. Okay, this is one of the best way to make complicated C double bond C from single molecule, simple molecule. Okay, that one one note. You know, when you make the unit, you need to use an SN2 reaction. SN2 reaction. Okay, so normally this one go with the primary alkyl halide. Primary alkyl halide. Okay, not tertiary, not secondary. Okay, so for example, if you want to make C double bond C, there are two ways. There are two ways. You can make from this ketone and this unit, or you can go from this ketone and this unit. Okay, okay. Always go with the less steric unit. I mean, look at the P double bond C and this P double bond C. The top one, the above one is less steric, less bulky than the below. Okay, so go with the less steric unit. Okay, remember that because when you make this unit, you need to use an SN2 reaction. Okay. Okay, and reaction I told you already. This you can reduce aldehyde ketone to make alcohol. Okay, the hydrogen here is negative. Okay, so you can make this one. Remember, if we use NABD4 or NABT4 or TO T3O plus or D3O plus. Okay, and you should know where the D, where the T say in your product. Okay. And of course, you know the Clemmensen reduction. You know Clemmensen reduction. I say again, you will see these two reactions in your midterm and your final Clemmensen reduction. Okay. Normally, when you reduce C double O, we have alcohol. But for Clemmensen or West-Kistner, the oxygen disappear. No more oxygen. Okay. And oxidation is very easy. We can oxidize aldehyde to carboxylic acid. Okay. Ignore this reaction. Okay. Ignore this reaction. Ignore this slide. Okay. You don't use something very cheap, expensive to make something cheap. Okay. Okay. That is the first part of the chapter. Okay. So now take a break. Take a break for 10 minutes and then we study the second part. Okay, now this is the second part of aldehyde ketone. The reaction of alpha carbon reactions at alpha carbon. Okay, look at the structure of aldehyde ketone. You know, C double bond O is electron withdrawing. C double bond O is electron withdrawing. Okay, so electron will move from hydrogen to this carbon. So this proton, this hydrogen is a little bit acidic. Okay, so we can use a base to remove this proton. And after that, we have an anion. This carbon become negative. Okay, okay. And this is negative, so it can react with whatever positive. Okay. So at alpha carbon, there are many important reactions. But in our program, we just study one reaction. That is the aldone condensation reaction. Okay. That is the reaction between two aldehyde or two ketone. Okay. Look at this one. Okay. So look at the alpha carbon. Remember, just pay attention to the alpha carbon. I mean the carbon next to the C double O. Okay. You just ignore whatever left. Just pay attention to the carbon next to the C double O. Okay. So we have a negative carbon here. This proton is a little bit acidic, so we have a base here, the OH, negative combined with positive proton, and then we have water, so we have anion here. This carbon is negative. This is the reaction between a strong base and a weak acid, so we still have neutral aldehyde here. Okay, sorry, I have a phone. Negative, so it adds to the positive carbon. Okay. So we have to have this product. The oxygen is negative, so it will take a proton from water and then give back the hydroxide anion. Okay, so eventually we have this one. Okay, we have this one. And at high temperature, we remove one water molecule. Okay, we have two options. We can take the proton here or we can take the proton here, but the main product is the proton here. Okay, so that we have a conjugated system here, C double bond C, and then single bond C and double bond CO. Okay, double, single, double. That is the main product. So remember, in this reaction, we always have a conjugated system, CC double bond, CC single bond, and CO double bond, double, single, double. Always, if you don't have that conjugated system, that means you don't have the correct product. Okay. In the chapter, we have some more reaction, but you just ignore it. Okay, ignore it. Okay. You don't have exams on this reaction. In this section, we just study one reaction. That is the aldone condensation reaction. Remember, we always have the C double bond C and then single bond C and double bond O, double, single, double conjugated system in the product. Always. Okay. So now I give you questions to do for this reaction. This reaction is important. Okay. Let me stop sharing it. Now I give you. Okay. Let me share it. Let me share the screen. Okay. Can you see the screen? Can you see the screen? Can you see it, everyone? Can you see it, everyone?
Yes.
Okay. So now look at this ketone, diketone. Okay, we have C double bond O, C double bond O. Okay, so give me the product of the aldone condensation of this one. Okay, remember elimination. You need to eliminate water so that we have C double bond C and then single bond C and double bond O. Okay. Then complete this reaction and upload your answer onto BKE Learning. Okay. Did you hear me saying that? Toán? In the product, we always have C double bond C and then single bond C and C double bond O. Did you hear me saying that? Toán? Okay, then correct your answer. ring, not 6-member ring. Okay. Let me share one examples. Let me share one. Nguyễn Phúc Thành. Okay, let me share Than's answer. Everyone, can you see Than's answer? Can you see Than's answer?
Yes,
everyone?
teacher.
Okay. You know, look, here you have 2 C the bond O. Okay. So here we have 2 possibilities, 2 options. Here we have 2 alpha carbons. It could be here, it could be here. And then that negative carbon will attack to here. But remember, I told you a couple of times, we make 6-member ring, 5-member rings, not 6, not 4, not 7. Okay. So if you take this alpha carbon, so we have 1, 2, 3, 4, 5, 6, 7. Okay, so not this alpha carbon, it should be this alpha carbon. So 1, 2, 3, 4, 5. So we have 5-member rings. 5-member rings. Okay. Eventually we eliminate one water molecule and we have C double bond C, single bond C, double bond CO. Okay. Okay, so this is the product. Okay. I mean the blue one. Everyone, can you see? Everyone, can you see my chem office? Can you see my chem draw? Can you see the blue one? Everyone? Can you see the blue?
Yes.
Okay, give me the product of the blue reaction, outer condensation reaction. Remember, ongoing step C double bond C, single bond C, double bond CO. Okay. And then upload your answer onto BK e-learning. Sharing it. Okay. Okay. Now it's time to do the test. Okay. Actually, I already mentioned this question to you already, but now do it again because this is very important. Okay, let me share the screen. Everyone, can you see the question? Question number 2. Everyone, can you see question number 2? Everyone?
Yes, teacher.
Okay. Okay. This question is very, very important. Okay. Try to complete this question. Okay. Details and submit your answer. Submit your answer before 11:45. Okay. 11:45. In your final exams, you will see something like this. Okay, again. And remember, in this question, we have many reactions related to the midterm exam, not just only the final. Okay, so do it very careful. Okay.